Hello everyone, welcome to the second part of the tutorial series about how to train a Hugging Face Causal Language Model from scratch with a custom dataset and a custom tokenizer. So you might remember that in the first part we have already converted data in a CSV data format into a Hugging Face dataset. In that part we are gonna learn how to tokenize the dataset. There are two options. We can use a pre-trained tokenizer or we can train our tokenizer from scratch. I will show both of them. Then we are gonna upload or push the tokenizer to the Hugging Face Hub. And then we are gonna download it. I will show all these steps in an example. Before delving into today's topic, I would like to introduce my channel briefly. At the Murat Karakaya Akademi YouTube channel, I share tutorials with source codes in English and in Turkish about artificial intelligence, especially how to implement deep learning and machine learning approaches with Python using scikit-learn, TensorFlow, and Keras libraries. If you are interested in artificial intelligence, deep learning or machine learning, and if you are looking for theoretical and practical information, please subscribe to my channel and activate notifications. When you subscribe to the channel and activate the notifications, you will be notified of live broadcasts and new uploaded content. Now, let's continue with today's topic. For tokenization, we will use two different approaches. The first one is we will use a pre-trained tokenization. The second will be training a new tokenizer from scratch. First, how can we use a pre-trained tokenization? From the Hugging Face Hub, we can locate several models and tokenizers trained with some Turkish datasets. Remember that we are gonna use dataset which is collected from Turkish websites, about 32 topics. In the first part I already explained. Therefore, I will look in the Hugging Face Hub some models trained on Turkish language. How can you find these by yourself? So if you go to the models, you can check the models, the languages. For example, let me check the Turkish language. I will use the GPT model for text generation. Here you see that there are several models trained on Turkish language for the model GPT. Let me show one of them here. If you check that, there is the interface to that model. Let me write some Turkish prompt and try that model. By the way, all the necessary files of a model is stored here in Files tab as a Git repository. So I can download. So in a model, when you upload a model, the Hugging Face API uploads the tokenization as well. So you can use this tokenization. So you can see here that the language model trained on a Turkish language dataset generates this text. So if you go to the files, you would see that in the model, it's not only the model stored here, but you see that the tokenizer already here, if you check that, tokenizer information already stored in that token. So I can use this model tokenizer in my example, in my dataset. Why? Because it is already trained for a Turkish language dataset. Okay. But let me give you some important information about the tokenization in general. In language modeling, tokenization can be done in two different approaches. If you provide a string which is larger than your expected tokenization, for example, if you would like to create a sequence with 40 tokenization on the 40 tokens, okay, there could be some strings generates more tokens than this. You have two options. In the first option, you can use the first n tokens from that sequence and then discard the rest of the tokens. The second method is that you can use all the tokens from the given text, which are separated by, for example, 40 tokens each. Of course, the end would be less than the 40 tokens. But you can use all the sequences, 40 token sequences, from the same text. You can use this. In that example, I will not use this approach. I will use the first n tokens from the text. Why? Because I want to train a language model, and in the end, I will use this language model as a text generator, automatic text generation task. Therefore, I would like to teach this model to learn the grammar rules of the Turkish language. For that reason, I will begin from the beginning of the Turkish sentence up to 40 tokens. But if I use the rest of the tokens could be generated from the text, the language model can learn or can see examples just starting from some part in the statement. And I don't want this. But some cases, you would like to not spare the rest of the text, and you would like to use the rest of the tokens as well. So if it is your idea, you can just focus on that parameter. Okay. In that parameter, you can provide true or false values. If return overflowing tokens false, it means that at the end of the tokenization process, you will receive only the first n tokens from the text. If it is true, then you will end up with all the sequences from the text. Okay. Okay, let's see that how can we download a pre-trained tokenizer from the Hugging Face Hub. First, you need to import the auto tokenizer from the Transformers, Hugging Face Transformers library. Then you can define the context length, so how many tokens will be generated at the end for each sequence. Then you can download the pre-trained tokenizer by using from pre-trained method and providing the Hugging Face user account and the model name. If you check this, you can see easily that if you go to the model card, all right, here is the name of the user, account name, and the name of the repo. So you can click here and you can copy this. Then you can paste here. All right. After that, when you download the pre-trained tokenizer, you can adjust it, configure it by providing several parameter values. One of them is that we provide the text to be tokenized. Here I just provide two samples from the train data set for the column review. Okay. When we say truncation true, the tokenization will only produce the first 40 tokens. And we set the max length of the sequence to this context length, which is 40. And as I explained, I set return overflowing tokens false because I want only the first 40 tokens from the text. And return length is true. It means that provide me the length of the sequences or the tokens. Here we can check that input ID is length 2. So it means that we have only two sequences because remember that we requested first two samples. And then each of the tokenization of these reviews, 40 tokens, as we set the context length or sequence length as 40 tokens. The second thing, you can just check that the vocabulary size. So you see that it is 50K vocabulary size. I just kindly remind you that it's not the number of the words, because we will see that it is the number of tokens, and the tokens does not necessarily correspond to a single word. It can correspond to sub-words. Okay, let me show an example for that. Now look at the Turkish statement here. In the Turkish statement, we almost have 10, 11 words and 2 punctuations. But if we use the pre-trained tokenizer to tokenize this and give us the token IDs, here you see that we have 19 token IDs. Actually, there are almost 10 words plus 2 punctuations, but in the end we have the double number of tokens. Let's see why it is like that. We can use the pre-trained tokenizer convert IDs to tokens method by providing these tokens here, these tokens. Now look at that. In our example, we have a word sürat, but it is symbolized by 2 tokens, sür and at. Look at the second example. That's a one word in Turkish, cargo. So it's the cargo in English. It is symbolized by 3 tokens, car, G, and OM. So basically, for one word, the pre-trained tokenizer use 3 tokens. If you think that the language model learns by tokens, the sequence of tokens, and it needs to understand the order of these tokens, if you increase the number of tokens for a given word, it means that your model learns a difficult job. As the number of tokens gets less, actually, statistically, your model learns better. Here, I would like to point out that we would like to create a tokenizer, produce much more comprehensive and compact solution. Here, we see that for 10 words, we have almost double number of tokens. So if you create longer sequences, if you want to create longer sequences, your model needs much more samples to learn this number of tokens, how they follow from each other. Especially for Turkish, you know that we add some postfix to create new Turkish words. It's a special language. It's not look like French or Latin languages. So it's really important that your tokenizer should be compact. For that reason, I strongly suggest that to train your tokenizer. But of course, if you are working on English, you could find many more pre-trained tokenizers for very large data corpuses. So you don't need to do this. But if you are working on some languages like Turkish, it's a good idea to train your own tokenizer. Otherwise, if you use the pre-trained tokenizer for the same language, even, your tokenizer might produce some tokenization which is not easy for the model, not so useful for the model. Therefore, at this moment, I will show you how to train a new tokenizer. Okay. So in the official documentation as well, it is highlighted like that. If your corpus is very different from the one in your language model was trained on, you will most likely want to retrain the tokenizer model from scratch. Okay, that is important for us. First of all, to train a tokenizer from scratch, we need a data generator. As you know that we can create a Python generator for this. So if you check that I can create a function, actually a data generator by using list comprehension here and return this 10,000 samples from the dataset, and I can give this function a name, training corpus. Okay, let me show how this data generator works. We can get the reviews and we can print the length. You see that this generator each time returns me for the 1000th batch of samples. After we prepare the generator, now we can work on the tokenizer. Actually, we know that we are gonna use a GPT2 model, and in GPT2 model expects some kind of tokenization. If you want to create a tokenizer from scratch, actually you need to configure it by specifying about 20 parameters. Instead of setting up all these parameters for GPT2 model, we can use a tokenizer which is already work with GPT2. So I will use the tokenizer as a template for my dataset. So here you see that I will use the pre-trained tokenizer, but I just use actually the configuration of the pre-trained tokenizer because I know that this tokenizer is used in GPT2 model. So I will use as a template. Then here the Hugging Face provides me a method train new from iterator. So from iterator means that my data generator, and here I provide the vocabulary size as I wish. Okay. After I have the tokenizer, I can check the special end of sequence token ID or beginning of sequence token ID kind of, and you ensure that it is 0. It is important. If it is not 0, you need to go to the tokenizer config file and you can set it up 0 manually. Sometimes it happens. Now let's check the vocabulary size. You see that the vocabulary size is 4,400 around. Okay, I'm sorry, 44,000. Okay, it's not 52,000 because my data set, remember that, consists of only 4,000 reviews. It's a very sample of the whole data set. So the number of tokens is less than 52,000 tokens. Okay. Now let's see how the new tokenizer tokenize my sample. You see that now I have less tokens, remember, and check the locals, the tokens back to the strings. You see that now we have 1 token for the, remember, cargo, the Turkish word. So it is like that. So it is much more compact representation for my data set. If you check here the lengths of the tokenizers, the newly trained tokenizer use 11 tokens to represent the text, but the pre-trained one use 19 tokens. So that's the reason why I suggest you to train your tokenizer on your dataset. Much more compact representation of your text. At this point, you would like to save the tokenizer into your local file by using save pre-train model, save pre-train method, and then you can use from pre-train method to upload it and from a local file. So here you see that we can compare the train tokenizer and the loaded tokenizer are the same, right? Similarly, you can push the tokenizer to the Hugging Face hub so that you can use it anywhere or somebody else can use it. First, you need to log into Hugging Face account here. After that, you can use the push to hub method of the tokenizer by providing your account name and the repo name, Git repo name. And also you can download auto tokenizer from pre-train from your account. Then you can see that here I just checked that all these three tokenizer generates the same tokenization. We have achieved this second part of the tutorial series. In that part, we see tokenization in two different approaches. One version is to use a pre-trained tokenization. The second one is to train a new tokenizer from scratch using your dataset. And we also see how to save and load to a local file and how to push and download from the Hugging Face Hub. I hope you like this training. I would like to thank you for watching this tutorial so far. I hope to see you in the next part. Take care. Bye bye.